All right, so we are going to do trigonometry identity. Okay, if you can remember the previous video where we did r squared equal to x squared plus y squared. So this is the Pythagoras formula. And now remember, we can link this to the trigonometry ratio. Okay, so how do we link it? Remember, sine theta is equal to y over r, and therefore y will be, if we cross multiply here, r multiply, we have r sine theta. And then if we have cos theta, will give us x over r. So if we multiply both sides by r, we have x equal to r cos theta. So now, if we can replace them in this formula, what is going to happen? We'll have r squared equal to, instead of x, you put r sine squared, or sorry, you put r cos theta, all will be squared, plus y represented by r sine theta, so all squared. Therefore we have r squared will be, r will be squared, cos will be squared theta, r will be squared, and the sine will be sine squared theta. So therefore we can find the common factor here, which is r squared, and then we have cos squared theta, we have a sine squared theta. So if I can see, we have a r, we divide this side by r squared, I divide this side by r squared, so we have a cos squared theta plus sine squared theta. So if you divide, you cancel r by r, we have a 1, r squared by r squared, we have 1, so we remain with cos squared theta plus sine squared theta. So this is our first identity. So the first identity here, we have 1 equal to cos squared plus sine squared. So you can also write it in this way. If you can write it also, cos squared theta plus sine squared theta equal to 1. So this is our first identity. Very important. All right. Now, when you have this identity, from this identity you can find other identities. For example, you can say cos squared theta can give you 1 minus sine squared theta. Okay? Very important. Or you can have sine squared theta equal to 1 minus cos squared theta. So if you transpose sine or cos on another side. So now we have other identities that come from compound angles, but I will anticipate about that, where we have a cos 2 theta will give you equal to cos squared theta minus sin squared theta. Okay? So you can say, how do you get it? Remember, if you have a cos alpha plus beta, this will give you cos alpha, cos beta, minus sin alpha, sin beta. Now, if we say, now let's say alpha is equal to beta, meaning that instead of beta you put alpha, so we'll have instead of beta we have alpha, so it will be alpha plus alpha will be 2 alpha, and we replace here by alpha. We replace beta by what? Alpha. So what is going to happen? We have a cos 2 alpha, cos alpha times cos alpha will be cos squared alpha. Sin times sin will be sin squared alpha. Can you see? So this gives us this identity. So now, from these identities, if you can use now, you can use, let's use this one, okay? Instead of a cos, okay? Instead of a cos squared, we replace cos squared by 1 minus sin squared according to this formula. So we have a minus sin squared theta. So therefore we have a cos 2 theta. We have a 1. So minus sin will give us minus 2 sin squared theta. So this is another identity, this is a second identity. So when you have a cos squared, a cos 2 theta, you can change it to cos squared theta minus sin squared theta, or it can be 1 minus 2 sin squared theta. Now, if we use now, instead of a sin squared theta, let's replace sin squared theta by 1 minus cos squared theta. So we have a cos 2 theta will be cos squared theta minus, we replace here. Remember, there is minus here. If we put minus sin squared theta, or minus cos squared theta, therefore we'll have cos squared theta. We remove a bracket. Here will be minus sin, and here will be minus 1, sorry, plus cos squared theta. So cos 2 theta can be cos squared theta 2 cos theta minus 1. So another identity we have for cos 2 theta, we will have the first one we have equal to cos squared theta minus sin squared theta. Then we have also cos, we can have also 1 minus 2 sin squared theta. Then we can have a 2 cos squared theta minus 1. So this is the identity that we can have for cos 2 theta. So when you have a cos 2 theta, there are 2 or 3 possibilities sorry, where you can use. In some question, you will need to use cos squared theta minus sin squared theta. And in some question, you will need to use 1 minus 2 cos 2 sin squared theta. All right. Now, when it comes to sin 2 theta, this will be simply 2 sin theta multiplied by cos theta. All right. So this is the identity that you need to know, because you'll be using this formula. So I want to give you a question now. I want to give you an example, so you must make sure that you don't forget this. Or if you don't understand the question, you can go back, or you don't memorize the formula, go back to the video and then you can check again. So there is a question that I have here where it says you have to prove the identity, okay? You will prove this identity. So very simple one. Where is my question? Okay. The question says prove the identity. I'm sorry. All right. Now, let's prove this, okay? How do we prove these identities? It's very simple. What I like to tell the students, whenever you have a question of mathematics, the first thing you have to look at, there is any need of a common denominator, common factor, okay? The first thing, observe, check, look, think, and write down. The first thing I look at here, I say there is this side and there is this side, okay? And they are separated by the sign minus. So they don't have a common denominator, okay? So what I'm going to do, the first thing I have to find the common what? Denominator. Let me do this. What will be the common denominator? I have to multiply these two. I will multiply cos x minus sin x multiplied by cos x plus cos x. So I will have a cos x minus sin x multiplied by cos x plus sin x. All should be equal to 2 tangent 2x. What will happen now, numerator? What is simple when you're doing the common denominator? Just multiply this. Cross multiply. So we have a cos x plus sin x multiplied by cos. Now, you can see that they are same, eh? Cos x, sin x. And this side we have a minus. As it's same, you can just do cos x minus sin x all squared, because it is the same thing, okay? Also here, I can do the same thing, because cos x plus sin x multiplied by cos x plus sin x, it's the same thing. So which means I'll have a cos x plus sin x, all should be what? Squared. Now, if you remember this formula, I want to go back to the small thing, okay? A plus b squared. This gives you a squared plus 2ab plus b squared. So in this case, your a it's cos, and your b it will represent, your sin will be a b. Now, if you have a minus b multiplied by a plus b, you change this to a squared minus b squared. Okay, so look at this. We have a cos, b it's the sine, we have a minus, and then we have a plus b. So we have something like this. Can you see? We have something like this. So now we'll change all this, whether to the first formula or the second formula. There we go. So what is going to happen on the numerator? In our numerator, we'll have a cos squared x plus sin squared x, oh no, plus 2 cos x sin x, and then here will be sin squared x, and here will be cos squared x minus 2 sin x cos x plus sin squared x, all over. We'll have now cos, remember, as I told you, we have a minus, let's say this is our a minus b, a plus b, and then we have a sin squared. All right. Now, let me continue it here. All right. If I can continue, let me remove this thing, because my board is very small. So if you continue, you'll find something here. You'll find that we have a cos squared plus sin squared. Remember the identity that we did. If you can go back to the first part of the video, cos squared plus sin squared is equal to 1. And then we have 2 we have what? 2 cos, we can write it sin squared, sin x plus multiplied by cos x. It's the same thing, okay? Now, we can exchange here, there is no problem. Now, if we multiply here, it will be minus cos, okay? You multiply here, will be plus 2 sin x cos, and then here will be minus sin squared x, all over. Now remember the identity, cos squared x minus sin squared x will give you 2 cos x, okay? Now, what is very simple now, when you look at this, we move to we look at up here, we have a 1. But remember, the identity of a 2 sine cos will give you sine 2x. Now here, if we find a common factor, we'll have a cos squared x. With this one will be plus sine squared x. I'm just doing the common, I found the common factor between the cos squared and the minus cos squared and the sine squared. Therefore, here we have 2 sine x will give you sine 2x according to identity, equal to this, should be equal to that one. Remember, we have all over cos 2x. Now, when we come to this, we'll have 1 sin 2x plus sin 2x will give you 2 sin x. And then we have a minus. Remember, cos squared plus sin squared is equal to 1. All over cos 2x equal to 2 tan 2x. Now, 1 minus 1 we cancel, so we have a 2 sin 2x all over cos 2x. So you can see that we'll have a conclusion here. If I can remove all this, I think you can understand this now. What is simple now? All this, remember, sine over cos. Sine divided by cos give you tangent, and the angle is 2x. So we have now our our left hand side is equal to right hand side. Can you see? So it's proven. All right. So now, once we have this, you say, no, you did it. Very good. Now, let's move to the next example. I want to give you a next example. Let me pause the video. All right. Let's do quickly this identity. So when you look at this, the first thing you can think like to change this formula, the double angle. No, don't change the double angle, okay? So what you do here, you remember the identity that says sine squared alpha equal to 1 minus cos squared alpha. Okay, so all this, don't think about the double angle first. So you change it by square root, and then you change this to sine squared 2a all over. Now, when you have negative angle of a cos, because the cos it's even function, so you cancel minus. Now, when you have a 90 degrees plus, remember what we did in the previous video, this is a second quadrant. So cos in the second quadrant is negative. So you have a negative, okay? Then, cos of a 90 degrees change to sine 90 degrees because they are cofactors. Alright. Now, what will happen here? Square root. If you have a square root of a squared, you cancel this, the answer will be A. Okay? So when you cancel this, the sign will be sine 2A. Then we have a minus cos A and a sine A. Alright. Now, remember the identity of a 2 sine 2 alpha. So this will give us a 2 sine A multiplied by cos A all over minus cos A sine A. So cos A divided by cos A is gone. Sin A divided by sin A is gone. Then you have a 2 divided by negative, it will be minus 2. So that is the answer. Okay. Now let's go to the next example. Let me pause the video. Okay. We have a question here where we have cos of 2b. You can see cos of 2b equal to 3 over 5. And then they say the angle B is between 0 and 90 degrees. Now they say determine the value of the following. We can say the value of the following. The value of the following in its on its simplest form. Okay, so what you do here, it's very simple. Okay, it's very simple. Remember, we have cos 2b. So look at the formula of identity that linked cos 2 alpha or 2 beta with a cos beta. That will be 2 cos squared beta minus 1. Okay, therefore you just replace cos 2 beta, which is given to you by 3 over 5, and then we have a 2 cos squared beta minus 1. Then you solve. Then for you transpose 3 this 1 this side, it will be 3 over 5 plus 1, and this side will be 2 cos squared beta. Alright, now what is going to happen? Let me remove this with a simple calculation. The simple calculation that you will do, this will give you 2 cos squared beta, and this will give you 8 over 5. So if you multiply, you divide both sides by 2. By 2 you will have cos beta equal to 4 over 5. So cos beta will be square root of 5. You squared both sides, 4 over 5. So cos beta will give you 2 over root 5. So that is the answer. So why I took so long, many steps, because just to explain to you, but if it was myself, I can do it quickly in 3 steps. So now let's do the next question. You can use the same identity but by using sign. So we say cos 2 beta equal to 1 minus 2 sine squared beta. Or b. So we have a 3 over 5 equal to 1 minus 2 sine squared beta. So we can transpose 2 sine here, 2 sine squared beta. So when you transpose 3 over 5, this side will be 1 minus 3 over 5. So 1 minus 3 over 5 will be 2 over 5. So when you divide both sides by 2, you will have 1 over 5. So we have square root over 1 over 5. Okay, so sine will give you 1 over root 5, or sine beta will be square root of 5 divided by 5. Yeah, so this is how you can use the identities in a trigonometry. It can help you to solve many questions if you understand the identity. Thank you. The next video will be compound angle.